So now we are going to discuss about the unit and dimensional formula of various quantities. Already I have discussed in my first video about the unit and dimensional formula of fundamental quantities. Again I am repeating. There are 7 fundamental quantities: length, mass, time, temperature, amount of substance, current and luminous intensity. So now I'll first write my first physical quantity, that is distance, because motion is the first chapter. Already I have discussed the dimensional formula and unit of distance and displacement in my motion chapter. Still I am saying once again. So dimensional formula of distance is, distance can be explained using length only. So dimensional formula of distance is L, or else I can write M0 L1 T0. And what is its unit in MKS or SI system? Unit of distance is meter. Now displacement. Displacement is defined as the shortest distance between 2 points. Displacement is defined as the shortest distance between 2 points. So the dimensional formula of displacement and distance are same, unit are same. The only difference between distance and displacement is displacement is a vector quantity, whereas distance is a scalar quantity. You can watch my vector videos to understand all these things I have discussed already. So displacement also dimensional formula M0 L1 T0, because mass is absent, so M0, time is absent, T0, length is present, so L1. So basically distance and displacement are fundamental quantities because they can be explained only L. Unit is meter, here unit is meter. Now I will move to my next quantity, speed. Speed, the formula is speed equal to distance by time. Look, now speed is nothing but a derived quantities, because speed require 2 more quantities to be explained or to be defined. Speed is defined as rate of change of distance. So speed needs 2 more quantities. So these 2 quantities, distance and time, are fundamental quantities. So since a quantity is needing 2 more quantities to be explained or to be defined, that's why that quantity is called a derived quantity. So derived quantities are those quantities which can be explained using fundamental quantities. So distance, what is the dimensional formula of distance? Length. Dimensional formula of time is T. So now I can write the dimensional formula of speed as M0 L1 T minus 1. So this is the dimensional formula of speed, whereas the unit of speed is meter per second. So far we have discussed dimensional formula and unit of distance, displacement and speed. Now I am going to discuss about velocity. Velocity, you know, it is change in position with respect to time, or rate of change of position, or rate of change of displacement. So I am writing displacement by time. So the unit of velocity will be same as meter, same as speed, that is meter per second, and the dimensional formula will be, for displacement I am taking L, for time I am taking T. So this will be L1 T minus 1 and M0. So dimensional formula of velocity is M0 L1 T minus 1. Now I will move to my next fundamental quantity, that is momentum. Momentum, will be discussing about momentum in laws of motion chapter, which will be coming after motion in 2 dimensions. So my order of physics video is, first you go through vector, because this is a mathematical tool. Unless until you understand vector, you cannot understand motion in 2D. Then secondly, you can watch motion 1, that is motion in 1D. Then you can go for motion in 2D. Then you can start with laws of motion. Still I am saying or introducing the new physical quantities which will be coming in the due course of syllabus. So momentum is mass into velocity. I think this is there in 9th syllabus also. I don't know, I'm not sure. But momentum equal to mass into velocity. So dimensional formula of mass is M. Dimensional formula of velocity is L1 T minus 1. So now the dimensional formula is M1 L1 T minus 1. Momentum. Momentum is defined as mass into velocity. And what will be its SI system unit? For mass I can take kg, for velocity I can take meter per second. So SI system unit of momentum is kg into meter per second. Now I will define acceleration. So acceleration, you know, it is change in velocity with respect to time, or rate of change of velocity. So already I have told you, suppose you don't know what is the dimensional formula of velocity. So only one thing you need to remember is, that is formula. If you know the formula, you can write unit and dimensional formula. So velocity is displacement by time into other time, which is there in the denominator already. So displacement by time square. So for displacement I can take length L, for time square I can take T into T. So I can write L1 by T square. That will be nothing else L1 T minus 2. Here I can write M0. So M0 L1 T minus 2. If you can relate this with unit, you can also write meter per second square. This is the unit of acceleration. Meter per second square. For meter I can write L1. Per second square I am writing T to the power minus 2, or here T square. So basically from unit also you can convert it into the dimensional formula. If you know the unit, you can write the dimensional formula. If you know the dimensional formula, you can write the unit. If you know the formula, you can write both unit and dimensional formula. If you know the dimensional formula, you can also write the formula. Okay, and in next videos, future videos of dimensional analysis, we will know how to derive a formula, even if you do not remember a particular formula, but we can derive. So this is the beauty of dimensional analysis. Now, force. So force equal to mass into acceleration. Force equal to mass into acceleration. So the dimensional formula will be, for mass I am taking m. Okay, for acceleration already I have found here L1 T minus 2. So now the dimensional formula will be m1 L1 T minus 2. This is the dimensional formula of force. Whereas the unit of force is kg into meter per second square. Here it is written, for acceleration it is meter per second square, for mass it is kg. So now this will be Newton. So kg into meter per second square is Newton. 1 Newton equal to 1 kg into meter per second square. So this is the unit and dimensional formula of force. So work done is a scalar quantity because we can get work done using dot product of two vectors. So dot product of two vectors, this is dot. Force is a vector quantity, displacement is a vector quantity. If I multiply two vector quantities using dot product, then I will get a scalar quantity. So work done is force dot displacement. You can check this in my vector multiplication dot product video. So work done is simply I am writing force into displacement. So work done is force into displacement. So what is the dimensional formula of force? Already I have found out. M1 L1 T minus 2 and displacement is L1. So the dimensional formula of force will be M1 L2 T minus 2 and the unit will be force. For force I have taken Newton into meter. So 1 Newton into meter. For displacement I am taking meter, for force I am taking Newton. 1 Newton into meter is nothing but joule. So work done can be expanded using joule. So joule is a scientist, so I am using the capital letter in terms of unit. Okay, now potential energy. Why I am discussing all this formula? Because I think all this formula you have understood or you have learnt in your 9th standard syllabus. So potential energy equal to mgh. This is the formula. So what is mgh? M is nothing but mass, acceleration due to gravity, and height. I am writing mass into acceleration into height. So I have to write the dimensional formula of mass here. M, acceleration dimensional formula L1 minus T minus 2. L1 T minus 2 already I have mentioned. And height is a distance. So I can write L1. So the combo dimensional formula will be M1 L2 T minus 2. This is the dimensional formula of potential energy, which is same as work done. So we will be discussing a very, very important concept, my favorite concept in fact, that is work energy theorem. Whenever I am doing some work, I am losing some energy and that energy will be converted from one form to another form or transferred from one body to another body. That is the only gist about physics. In physics basically we are discussing about energy transfer, energy conversion, energy conservation. So it's all about energy. So work done, potential energy, dimensional formula same. That's why you can directly write the unit of potential energy joule. Similarly here I am going to do about the dimensional formula of kinetic energy, Ke. formula you know, half mv square. One more thing you should know here, half is a constant. So basically a constant for an integer is a dimensionless quantity. Constant do not possess any dimension. So I can only think of the dimensional formula of mass and velocity square. So what is the dimensional formula of mass? Capital M. Velocity square, for velocity I know dimensional formula of velocity is L1 t minus 1 and square. So what I can write, M1, now L1 to the power 2, L square, now t minus 1 to the power 2, t minus 2. This is the dimensional formula of kinetic energy and the unit is joule. So what we have observed, the dimensional formula and unit of work done, potential energy and kinetic energy are same. So now I am going to discuss about power. Power, almost you have known these things in standard 9 syllabus. So power is defined as a rate of change of work or work done by time. It is again a scalar quantity. Work done, we have already got M1, L2, T minus 2. And time is T. Work done we have already got M1, L2, T minus 2. So the dimensional formula will be M1, now L square. Now T is below, T is going above. So this will be T minus 3. So dimensional formula of power is M1 L2 T minus 3. And what will be the unit? Unit is what? You know about the unit. Or you can write joule per second. Unit is joule per second. This is power. Now impulse, a new quantity. Impulse is force into time. So since impulse is force into time, for force I am taking M1, L1, T minus 2, and for time I am taking T. This will be M1, L1, T minus 1, which is also same as momentum. I have already discussed about the dimensional formula of momentum. So momentum dimensional formula and impulse dimensional formula are same, unit is same. So you can write the unit force into time, Newton into second, or you can write from here, for mass you can take kg, for length you can take meter, for time inverse you can take second. Kg into meter per second is nothing but Newton into second. So this is impulse. Now next important derived physical quantity is torque. Torque is nothing but force into distance. I will discuss more elaborately in my future videos when I will discuss about rotational motion. So torque is force into distance. So it is same as force is M1, L1, T minus 2 and distance is L. So it is also same as work done, M1, L2, T minus 2, and the dimensional and the unit is Newton into meter. So this is torque. Now next thing is I am going to talk about one more thing that is known as pressure. Pressure equal to force per area, you know. So from this formula also you can write dimensional formula. For force I am taking M1 L1 T minus 2 and for area I am taking L square because area is length into length. So M1 L2, if we take it to numerator part, it will become L raised to T minus 2. So minus 2 plus 1, minus 1 and T minus 2. This is pressure. Now density. So I am going to write about density and the unit of pressure is Pascal or force per area Newton per meter square. I am writing the unit of pressure Newton per meter square. We can measure the pressure in terms of atmospheric pressure, ATM, Pascal. You will come across this in your favorite chapter in chemistry, that is gaseous state. Newton per meter square gone. Now I will go to pressure and after that I will be talking about density. Okay, so density equal to mass by volume. So for mass I am taking dimensional formula as m, for volume I am taking dimensional formula as L cube, because volume is nothing but distance cube, length into breadth into height, L cube. So distance cube L cube. So m1 L minus 3. So density and the unit will be kg per meter cube. So from all discussion of some derived physical quantities, you can learn formula, dimensional formula, unit, and how they are correlated. So basically you need to understand the formula. If you remember the formula, then you can write unit and dimensional formula. That's why in the starting of my first video on dimensional formula and unit, I have mentioned that unit dimension is a chapter that can be studied or completed along with all the chapters of physics. So I think this is much about all the physical quantities. We will discuss some more physical quantities in due course of our syllabus, that is current, charge, electric field intensity, electric potential, electric dipole moment, flux, magnetic field, so many things, impedance, resistance, potential difference, conductance, conductivity, resistivity, so many new things will be coming in our plus 2 second year or 12th class syllabus. So stay tuned, watch, subscribe and like. But after this I will teach what is the beauty or what is the application of dimensional formula. So basically I am giving you one trailer of my next video, that is I'll discuss application of dimensional formula or dimensional analysis, like derivation of new formula, conversion of unit, checking the correctness. Then after that video, I think that will be my third video on dimensional formula, and in that video I will complete application, and in my fourth video I will be telling the most important concept from unit and dimension, that is errors in measurement, which is very very important, and entrance questions, plenty of entrance questions. I think almost you can get 1 or 2 entrance questions from unit and dimension every year related to dimensional analysis and error. Thank you.